Okay, now for the next one here, right, we have x squared plus 5x plus 9. So A is 1 in this case. B is 5, C is 9. So let's figure out the vertex. Even though it's right here, let's see how we get it. We have negative B over 2A, which is negative 5 over 2 times 1, which is negative 5 halves. Right? I'm just substituting B and A. So what we have here is 2.5. We have y equals, so that's negative 2.5. So this probably should have been a negative 2.5 squared. I mean, we're still going to get the same answer. Let me just fix that quickly. There we go. Plus 5 times negative 2.5 plus 9. So we do end up with this, as you can see. So this is the y coordinate of the vertex. Here's the axis of symmetry. That's the equation for it. And again, since A is positive, we know it has to open upward. Oh, wrong button. Sorry about that. It's going to open upward, so the graph's going to do something like this. As you can see, so the graph, the range, right, that's going to go, the vertex is down here. So the range is going to start at the y coordinate of the vertex, and it's going to go up. Now there's something else here that hopefully everyone saw that was working on this. The vertex is in this quadrant, right? Negative x, positive y. It's also going upward, as you can see. Well, can this thing pass through the x-axis? Well, no. It's going up. It's going away from the x-axis. So this graph is not going to pass through the x-axis. And what does that tell us? There are no x-intercepts. I mean, we'll confirm that in a second, but ahead of time, it's good to see that we should expect there are no x-intercepts. So in the quadratic formula, if we get otherwise, then something is wrong. Well, the y-intercept is just 9. You just replace x by 0, as you can see. From here, right, we plug it in, the quadratic formula. We get this. And see also that 5 squared is 25. 4 times 1 times 9, right? We have 25 minus 36. But that's a negative. So we have the square root of negative 11 here. That's not a real number. It's a complex number, but it's not a real number. And so because of that, there are no x-intercepts. So yeah, what we have, we confirmed. Okay, well, let's graph it. And so we have the graph here, and we can see, yeah, there's no x-intercept. Okay, the range, you know, we can see as well as the this is the y-intercept, and so on. All right, that's good. So that's this example. Are there any questions about that? Okay. Oh, this was just something else, like the observation, like even before graphing, we could see that there would be no x-intercepts, you know, beforehand. That's what I said already, though, so. All right. Well, remember also, we had this equation, right? That was the standard form of a quadratic function. I mean, we were mostly working with the other form. This one does have advantages. 1, you can read the vertex, you can get the vertex immediately, right? We have H, K. That's the vertex. This A is the same A as an AX squared plus BX plus C. It's the leading coefficient. But what's nice about this is if we know our quadratic function has to pass through a certain point, and if it has a vertex, we can actually get an equation for it right away. We can get an equation for it right away. And it's through this standard form. That's what I'm going to show now. Suppose, for instance, we want to get a quadratic function whose vertex is 2, 0. And we know it has to pass through this point. Well, so the vertex is 2, 0. The vertex is HK. So we know that this has to be true. So from here, we get H equal. So we have these 2 points equal to each other. So that tells us that H must be 2, K must be 0. So we get H must be 2, K must be 0. Okay, that's good. Because now we know what H and K are. So we plug them in, and we get f of x is this. Are we done yet? No, we're not, right? We don't know what A is. But we do have something else that's given to us. We know that the vertex must pass through this point, 1, 3. So since the vertex passes through the point 1, 3, we can use that. That is, f of 1 we know has to be 3. F of 1 has to be 3. Let's plug it in, see if that helps us. We get, when you replace x by 1, we have to get 3. So we know this has to hold, which is the same as this. But 1 minus 2 is just -1. So we have 3 is A times minus 1 squared, which of course is just A. So we get that A has to be 3. So again, using this, right? We replace x by 1. We know we have to get 3. So we have 3 is f of 1, which is this, which is equal to this. And so from here, we get this, which is just A. Because -1 squared is 1. We get just A there. So now that we know what A is, we know what f of x looks like. That was fun. Let's do another one. Are there any questions about this one? Okay. Well, let's consider this now. Let's now find a quadratic function whose vertex is 2, 4, and it passes through the point 4, 7. Okay, so we know the vertex is 2, 4, so HK has to equal to 2, 4. I should put this on the left side, because the unknown goes on the left side, but I guess it's okay for now. Since these 2 points are equal, their coordinates have to be the same. In other words, H has to be 2, K has to be 4, as we have over here. Because of that, we get f of x, okay, is A times x minus 2 squared plus 4, right? In the general form, see if I can get back to it quickly, we have this. So H we get is 2, K is 4. Remember, it's always x minus H. If H is negative, then you're going to have plus here. But we need to know what A is. How do we do that? Well, we know that 4, 7 is also on the graph. which tells us that f has to send 4 to 7. That is, f of 4 must equal 7. So we have f of 4 must be 7. So it's just like the other one. We can use that to figure out what a is. Now, if you're given something, you really want to use it. We're given that 4, 7 is on the graph. So we have 7 is f of 4, which is also this. F of x was this. So we replace it. We got to figure out a. Well, the right-hand side, as you can see, is a times 2 squared plus 4, which is this. A times 2 squared plus 4, which is 4a plus 4. And here I'm just solving for a. I put the unknown on the left-hand side. That's really what you're supposed to do. I'm not going to take off points if you don't do that, but we have 4a plus 4 is 7. So we subtract 4 from each side. We get 4a equals 3. And then we just divide by 4. So we get a is 3 over 4, and this is what we get. I mean, if we wanted to graph this and do like what we did before, I would FOIL this out. You know, FOIL meaning multiply it out. So, okay. Let's see, we're close to the, all right. I mean, originally I was going to have everyone try some, but we're really low on time. So what I might do is, I'm thinking maybe we'll try that next time, or I'll just jump right into 3.2, I think is the next section.